Alright, after today, no more sleepless nights. Here is the crazy piece of plastic. If we rotate it clockwise, it will reverse direction. It, to me, sounds like a violation of the conservation of angular momentum. If we rotate it counterclockwise, that does not happen. The object is called a rattleback. And I want you to read the Wikipedia article about rattlebacks. Also ask for videos. You will see many videos about them. Let me first tell you what does not cause it. No magnetic fields. No electric fields have anything to do with it. No piezoelectric fields. There's no liquid inside. And it has nothing to do with the rotation of the Earth. Some people think that if it reverses in the northern hemisphere in this direction, that in the southern hemisphere it would reverse in the other direction. That would be a little bit bizarre, wouldn't it? So that's also not the case. So what causes it then? Well, physics is complicated, way more complicated than you may think, than I would have thought. Clearly, the bottom line is that there is asymmetry in the mass distribution, but that alone may not be enough. This piece has an axis in vertical direction, and it can rotate about that axis. It has an axis in this direction, and it can rock about that direction. And then it has an axis in this direction, and it can rock about it in this direction. So this axis, it can rotate in this direction. This axis, it can rotate in this direction, rock in this direction, not rotate, rock. And then this axis, it can rotate about the vertical. It is designed in such a clever way, which all by itself is amazing, that if you rock it, that it will start to rotate counterclockwise. In other words, if you rock it, there will be a frictional force which comes from the table, and that frictional torque is in counterclockwise direction. Look at it again. In other words, that's its preferred direction of rotation. And once you stop rocking it, of course, the frictional torque will reverse in clockwise direction and it will just come to a halt. So that is all by itself amazing. Which is even more amazing to me is that when you rotate it clockwise, that there is a coupling between this rocking motion and the clockwise rotation. And some of the rotational kinetic energy in rotation goes into rocking energy. And when that happens, the moment that it starts rocking, it wants to reverse. So let's look at that. You see it start rocking, and then it goes back. Once more. You see it starts rocking, and then it goes back. If you make any piece with very asymmetric mass distribution, that doesn't mean that it will have this behavior. What I did was, I took an apple and I sliced this peak out of the apple, this piece, you see that? Now the mass distribution is very asymmetric, but it doesn't have the properties that I had hoped it would have. Clockwise direction, it just comes to a halt, no reversal. Counterclockwise direction, no reversal. So the bottom line is that it's not all that easy. Yes, it's due to asymmetry, but not any asymmetry will give you this performance. If you look at the videos, you will see that some people build a piece that at first does not reverse. And then they add some weights on both sides, and then it will reverse. That is quite remarkable. So, enjoy playing with it. And if you succeed in building one yourself, which you should with some efforts, by all means do let me know. I will give you credit for that. Well, you may not pass your 801 course, but for sure I will give you credit. Take care, have a nice day, and see you again.